Good morning, everybody. Welcome to Demystifying Containers for Beginners. This is going to be a nice, quick hour. Hopefully, it's going to feel quick for you as well as quick as it feels for me. We should get through everything, and we'll have time for some questions. Again, you have use the question bar there, and we will get to your questions when we can. The communication on a webinar, I know, can feel sometimes one direction from the speaker, but we'll do our best to be responsive to those in line. My name is Andrew Conniff. You can reach me at any of these excuse me, my email or on LinkedIn or through on Twitter, and any of those, you can reach me there. I'm a Senior Cloud Solutions Architect for Opsgility and Skill Me Up. And we will be going through our course in this order. We're going to talk a little bit about understanding containers. We're going to go through an introduction to Docker, and we're going to talk about actually containerizing an application. And through that process, we hope to demystify containers for you. So let's talk a little bit about the origins of containers. And again, we're very much approaching this from people who have just barely heard about containers. Hopefully you know a little bit more than that, but we're going to approach it from the very, very beginning, give a little bit of a background history of how we end up sort of adopting containers more than we used to in the past, even though they've been around for some time. And then we're also going to go through the ins and outs of sort of how to build them. But let's start at the beginning, where we were talking about how did we end up starting to hear more about containers. For core ID, a lot of times IT, we've worked a lot with like virtual machines. We've learned that we can move those to the cloud. We've got all of our applications that we're moving. And so a lot of us are in this digital transformation phase. And one of the things that's happened is, alongside the digital transformation of our regular businesses, some unique businesses have come about and started working with large amounts of data. They've taken this idea of containers and made it a lot more, they've democratized it to make it easier for developers to use. And so that's kind of where we are today. So what's happened is we have this business need where we're definitely seeing a lot of companies make this transition and get to this rapid innovation and transformation of products. And traditional IT tends to feel like it's very much lagged behind. I've got a question saying, is there audio? And so I'm wondering if they may have problems with their speaker. If we could get someone to send a question in to confirm that they are actually hearing us. I've got a live microphone, and I know I've got some folks on the phone that we mic tested. Okay, looks like someone else is good. All right, so maybe we could, I've got to have a teammate that can respond to that person directly, maybe help them out. If you could, Adnan, that'd be great. So to keep going where we are, so we have this rapid innovation that's happening sort of around us if we're in core IT and we're working with our own data centers. And on the other side of it, we're trying to say, well, we want to start participating in this. And the problem we're facing is our IT budgets are still heavily focused on these, the maintenance and keeping the lights on of these data centers, maintaining our virtual machines, and basically maintaining the status quo. But there's this ever-changing security and compliance requirements, and it's just hard to shake up the budgets to find a lot of that. And that's led a large amount of digitalization, a large amount of conversion to the cloud, because there's this, you can go through and you can use these pricing calculators, and you can find out exactly how much you're going to save over time in the future to take the bump up front to start moving things to the cloud. When we move to the cloud, some of these other technologies make a little bit more sense to us. So on our journey to the cloud, there's generally these five, the 5 R's, right? The approaches that we can take. We have our existing on-premise applications there on the left, shown on the left. And so the way this chart goes to sort of explain this is before we go through it. On the right, we've got the agility and time to market and the total cost of ownership and IT simplification. And on the left, we have the sort of engineering and cost time. So it's kind of flipped though, right? So let's just kind of go through it. So on the left, we have at the very bottom, doing nothing, not doing nothing, but maintaining the status quo, where we're sort of stuck in this cycle of maintaining our VMs and all of that on-prem. We want to start moving to the Rs, which are either rehosting, refactoring, re-architecting, rebuilding, or replacing our applications that we already have. And this is the conversation, right? So each application should actually go through and have a sort of a top-down look. Like maybe you really, really, really love your email system that your company built for itself, but maybe there's an email system that works for your entire company that is a SaaS offering. I know a lot of companies have adopted something like Office 365 or like some other email systems that work from the top down. And that's a good example of an application that it no longer makes financial sense to maintain because you're going to be on a deficient product that's you just can't keep up with the rapid improvements of some of these systems. But where most of us live is in this: do we rehost our VMs? And probably the answer to that is going to be yes for a lot of our applications. Do we refactor our applications? And that can be not only containers, and the reason it says containers there is that that's where that starts to creep in. And you can also do app services, and you can do other things, but you can do containers in app services, and you can do containers using orchestrators like Kubernetes too. So it kind of fits in that refactor where you don't actually have to change your code a whole lot to make it work. And then there's re-architecting, which you could do with Service Fabric Mesh, or you can also do with Kubernetes and containers. And then there's a rebuild, which is just do a new greenfield application and say, we're just going to start with the problem we solved in the past, and we're going to use things like Azure Functions, Logic Apps, and a combination of things like containers and messaging, cloud-built services that are either serverless to run or are services that you just use on the cloud, like messaging and whatnot. And then the last option is replace. And this is usually the last option because very, very few things are perfect when someone else builds them. So they don't work perfectly for our company. The rare exceptions are things like, Office 365 or whatever our word processing and email and whatnot. That's something we generally don't want to spend a lot of time building ourselves. So that's where we fit in how we are going to, on how the containers end up in this conversation as far as what they do. So we're going to briefly go through this part because we're going to get to the fun part of the new stuff. But the old approach was everything ran on servers way back in the day. Our applications, one application per server. After that, there was this, and this is the story of containers now, right? So we've told the story of IT, and now we're going to talk about the technology. So when business needed new applications, they would buy new servers, and then virtual machines came along, so hypervisors, and we were able to get more applications that could run on one server. And so now you've got multiple virtual machines running on a server. Again, because growth is something that people tend to be somewhat optimistic about, and core IT has learned that if you underbuy, you end up possibly paying top dollar for more machines. Developers, I have a developer background. I always want the fanciest machine with the best processors and all the cool things. So you have a lot of push in technology to buy the latest, greatest thing. But again, what we basically end up with is servers that are not fully used and data centers that are running power to a lot of stacks of blades and whatnot. And then you also have the air conditioning and the security around your buildings and the badging and the people and all of that. And so this isn't to make that go away, but this is sort of say, hey, this old approach has its limitations and it has some great benefits that we're probably going to keep. But if we could offload a lot of the workload into the cloud, we can get somewhere. So here's the virtualization visualized here. So when we went to the VMware and hypervisors, we already kind of talked about this on the last slide, but we'll run through this really quick. So we get to maximize value. Again, we're able to add more operating systems and more, virtual machines and run different types of applications and really expand out. But every operating system consumes CPU and RAM and storage and all of that. So we've, as we're moving out of that, we're moving away from this virtualization as part of our story. And then that brings us to containerization. So containers aren't new. Some of the large software companies like Google have been using containers for a long time to address the shortcomings of virtual machines. And in the container model, the container is similar to the virtual machine concept that we kind of outlined before. What it is the major difference is that every container does not require its own operating system. So our story went from one application per server to virtual machines. They all required upkeep of their operating system. You have to keep them patched and hosted and securitized and all of that, to now we can run virtualization on top of an operating system. So we've moved one level above that. And then there's there's a container engine that's going to run our applications for us on top of that. So all containers on a single host have to share that one operating system. And that's huge because it frees up a large amount of system resources. So the CPU and RAM and storage are all freed up inside that container. It also reduces your licensing costs and reduces the management overhead that we've been talking about. So the patching and monitoring and whatnot. The net result is a significant savings on the capital expenses and the op expense. So didn't go too much into that earlier on, but the capital expenses is your hardware and machines, and your operating expenses would be like cloud spend. So unlike virtual machines, containers are also very fast to start and very portable. So moving containers from your development machine to the cloud is a lot more simple, and you can even move your containers to virtual machines or physical servers as you want, so back and forth as you would. So now we're at this point in time where we have containers. Google and large companies are using it. The rest of us at this time are still mostly using virtual machines. And this is where Docker comes in. So if you're familiar with images a little bit and containers, then you've probably heard of Docker. If you haven't, this is Docker. So modern containers, they started in the Linux world. Google was and is still one of the largest contributors to the container-related technologies like linked to the Linux kernel. And containers, as they were introduced to the world, are still pretty complex and approachable when they first came out. And it wasn't really until Docker came along that the containers became available to the masses. And so what happens is there's like the Docker magic is it makes it usable for the rest of us, and they're a little more simple to understand. So the Docker has come up with an API and a set of commands that allows us to execute and make images for our images and then run those images as containers. So Microsoft has worked to bring Docker and container technologies to the Windows platform. Windows containers are available in Windows 10 and Windows Server 2016. The user level tooling to work with these Windows containers is Docker. It's what allows the Docker experience to be essentially the same on Docker and Linux as Docker on Linux for Windows. So if you use Docker on Linux, you'll feel right at home using it on Windows containers. It's important to understand that a running container shares the kernel of the host machine it's running on. This means that a containerized app designed to run on a host with a Windows kernel will not run on a Linux host. So how this works on your laptop, if you're going to go and play with Docker, which I highly recommend, is Docker will run, it'll create a runtime either for Linux or Windows on a Windows machine if you're on Windows. So you can pull and run Linux containers, but you can't be running them at the same time. So you choose the running mode of Docker when you're working, and then you can switch fairly easily from Linux to Windows. There's not a lot of information about Mac containers out there, but if you're running Linux, a lot of times you can get, again, you can have Docker on Mac, you can run it on Linux, and you're going to be fine. And another term that we might be talking about soon We're going to mention it a little bit, but we're not going to do a whole lot with Kubernetes. Kubernetes in and of itself, we'll discuss what it does. We're not going to spend a whole lot of time building it out because we are only here for an hour, and that's going to take us a little bit longer, but we'll leave you with a good understanding of what it is. And then that's another thing that you would then want to spend maybe an hour or so digging into an introduction to that. But it's an orchestrator, and we'll talk a little bit about why we would need an orchestrator later on. But Kubernetes and a lot of these other technologies, because they're not the same company, they use Docker a lot of times for their commands. So the commands are very similar. So adopting the actual added technology is not like having to learn a new programming language. Once you know Docker, once you can get it running on your machine, you can start adopting things like container instances from Azure or Kubernetes, and that can be Azure Kubernetes or Kubernetes somewhere else. And a lot of that has to do with the piece that starts and stops containers, as well as pulls images, whatever. It's going to be Docker. It's going to be continuous along there. The interface to the runtime, the container runtime interface is pluggable, and that's what makes it easy to swap out Docker for different container runtimes in the future for things like Kubernetes. So they've taken care in creating this the set of applications that can use things like Docker, but if something comes along that's better, you'll be able to plug that in and keep using like Kubernetes and other container runtimes. So to summarize this section, the world we lived in, used to be that businesses wanted a new application. We had to, buy new servers for it. We had to invest a lot of time in it. Virtualization helped improve that. Most of us, I think, have been working in the virtualization age, where we can drive a lot of value out of a single server by adding in its virtual machines on top of that. But again, we still had some of the same things weighing us down. And then we have the more efficient and lightweight virtualization technology called containers, which allows us to take the existing applications, create an image of them, and then run them in a container. But containers were initially very hard to use, so they've been around for a long time, but haven't been implemented because of the significant investment it would take to bring a small core IT team along and write all the code that you would need to run it. Now we have Docker and a lot of other container technologies that have been written already, and we can use them to containerize our images. So again, one point I think I may have brushed over, I want to make sure that it's comes across, is you can think of these containers as, or the images for a container as like a stopped VM template. And then when you run it, the container is the runtime. So the image is the template and the container is the runtime. All right, so that brings us more into what Docker does. So we're going to talk a little bit about this, and we're going to run some images and whatnot. So let's talk about Docker, the company. Well, Docker, when people say this, so again, you've probably heard the term Docker, and there's more than one thing that it can refer to. So let's break that up real quick. So they can be referring to either the Docker, the company, Docker, the container runtime and orchestration technology, or they can be talking about the open source project called Docker, which is now called Moby. So that'll help with that. If we're going to understand the containers, let's talk a little bit about each of those, because the important part is the container runtime part. So Docker is software that runs on a Linux and Windows. So again, you download Docker, you sign up for a free account. It creates and manages and orchestrates the containers on your machine. The software is developed as part of the open source Moby project on GitHub. So you can find the source code for it. You can go look at it if that's your thing and see what it does. Docker Inc. is the company based out of San Francisco, and it's the overall maintainer of the open source project for Moby. And Docker Inc. also offers commercial versions of Docker with support contracts, et cetera. So there's levels to what you can do with them. A little bit of history for those who are trivia minded. Docker Inc. started its lifetime as a platform as a service provider called .cloud. And behind the scenes, .cloud platform leveraged Linux containers to help them create and manage these containers. They built an internal tool that they eventually nicknamed Docker. And in 2013, .cloud was struggling, and they pivoted and rebranded the company as Docker Inc. and started that journey to bring those containers out to the world. And we've already kind of covered how that's implemented the rest of us as we're now taking courses and learning more about containers. So Docker is a number of things as people refer to it. And among those things, it's a file format for containers. It's a set of management tools. It's an ecosystem of pre-built containers. So as we go through this hour, you'll hear Docker, and we'll try to delineate between whether, what we're talking about. We'll try to say things like Docker file or Docker engine, even though a lot of times you'll hear them just referred to as Docker. So Docker allows us to package an application with all of its dependencies into a standardized unit. The Docker containers wrap up a piece of software in a complete file system that contains everything it needs to run. So it's got the code, a runtime, system tools, and system libraries. And it's anything you can install on a server. And that guarantees it will always be the same regardless of the environment that it's running in. So if it's Linux, it's got whatever Linux kernel it needs to run, whatever utilities it needs, but that's it. So when we talk a little bit further on, we're gonna see that there's the goal of every container or every image that you build is going to be to make it as small as possible and have it run perfectly. And then once that's done, you can deploy that image anywhere that has a runtime for images, and it'll be the same. All right. So, but when a lot of people say Docker, they're talking about the Docker engine. So let's talk a little bit about that. The Docker engine is the infrastructure plumbing software that runs and orchestrates the containers. So if you were ever a virtual machine, a VMware admin, you can think of it as being similar to ESXi in the same way that that's the core hypervisor technology that runs virtual machines. The Docker engine is the core container runtime that runs containers. So all other Docker Inc. and third-party products that plug in a Docker engine build around that. All the products in the diagram build on top of the engine and leverage its capabilities. Don't have a diagram to show you, but that's somehow it ended up in my notes. But you can be downloaded from the Docker website. So when you install it, you basically get that. And we're going to be using the Community Edition, and you can do almost everything on the Community Edition. The Enterprise Edition is going to be for a lot more high volume and if you need support. So it's available for free, and we highly recommend it. If you're just getting into Docker, you should create that free Docker account, get the Community Edition of Docker installed on your machine, and go through all the setup steps so that you can connect to it through your favorite command line. I use PowerShell, and we'll see that here in a minute. All right, so the Docker Engine Edition, Enterprise Edition is an enterprise-ready platform. It's a subscription software and support, and we're not going to talk too much about that. So that's something you can read about on the website. Now, you might be wondering, is Docker the only option? Is it going to be the way it is? There is this container ecosystem that we've talked about when there's an open container initiative called OCI. So as going forward, as other companies come in and maybe they want to build something like Docker or they want to do some other things, they can use this OCI that follow the governance and council responsible for standardizing those fundamental components. And that's how we end up with very similar technologies that run the same way. So the brief history on that is there was a company called CoreOS. And they didn't care for the way Docker did things, and so they created a new open standard called App that defined things like image format and container runtime. And they also created an implementation of the spec called RKT, pronounced Rocket. So at that point, then you have two competing standards, and we all know two competing standards, how that worked as far as developers. If you've ever wanted to build something if you work on Windows and then you want to build something for the Mac, that's a painful thing that a lot of new languages have helped us overcome. But both companies came together and formed the Open Container Initiative. So early on, they've learned the lessons, and so they've created this lightweight, agile council that governs container standards, and then all of them can now keep everything in line to the specs. And then if they want to add changes, they go back to the council and say, this is the new spec we would like to run. So right now we have the image spec and the runtime spec. And the key takeaway here is that there's now a government body that's going to make sure that we as developers, consumers of these technologies can switch between the ones that we want, try a few out, and we're going to end up with ultimately an engine or an image that can run based on the image spec or the runtime spec. So the point of that is if you're on this call because you're maybe leading an IT core team and you're deciding whether you want to go to containers, the risk of this being a singular siloed technology has been addressed early on. So that's kind of the point of going through that history, is to say that there is already this council, there already are specifications, and there already are companies out there who are competing in that space and making good software that we can use. So it's going to stick around. It's not going to be, we're not hinging everything on this one open source project, Moby or Docker. But to summarize what we just went through, the Docker was a startup company out of San Francisco that's an open source and lives in the Moby repo on GitHub. And there is this open container initiative that was formed to standardize the container runtime formats and container image formats, and make it a lot easier for us to use, a lot easier to adopt as a larger company going forward, knowing it's not going to disappear from us. All right. So now we're going to talk a little bit about how the Docker engine works. So the Docker engine is that core software that runs and manages the containers. We often refer to it simply as Docker or the Docker platform. It's modular in design, and there's a lot of swappable components. So where possible, these are based on open standards outlined by the Open Container Initiative, the OCI. So the Docker engine is made up of many specialized tools that work together to create and run the containers. There's APIs, an execution driver, runtime, and some shims. The major components that make up the Docker engine are the Docker daemon. That daemon is the brain behind the whole operation. When we look at some of the challenges that we have running Docker, maybe it's like we do things like runbooks. There's other technologies out there that help us deploy to the cloud. We have to be sometimes creative on where we're delivering our Docker, because we have to have that Docker installed. The Docker engine has to be installed so that the daemon can run. And there are certain cycles of long-running processes and machines, and where the daemon can end up just turning off, and it can be hard to bring it back online. In the Windows world, we could call it a service. It's a service that runs on a host machine and manages container lifecycle, and it also connects to host services like networking and storage. So again, think of it as it's a running software on your machine. It has to be there to run those commands. So the next thing is going to be Containerd. That's an industry standard container runtime with an emphasis on simplicity, so it's very lightweight and simple to use. Make sure that Docker images are presented as valid OCI bundles. So again, there's the validation check. And it manages the container lifecycle operations, so you can do things like start, stop, pause, etc. container. And then there's the runc, and the reference implementation of the runtime spec from the OCI. So that's your runtime layer. So all of those things are part of that Docker client. The Docker client provides the tools to interact with the Docker engine. With the Docker client, you can manage your Docker engines running locally or on remote servers. And it comes with a command line interface that runs on all popular platforms, so Linux, Windows, and Mac. And so those are the components you're going to have that you can use to create and run containers locally. So if you want to start a new container, let's walk through the process of actually creating one. So the most common way of starting containers is using the Docker command line interface. The command shown here will start a new container based on the Alpine latest image. So let's run through that command at the top. So we've got Docker as the first command, container, and then run. So Docker container run, you're telling Docker what to do. And then you're giving that container a name. So in this case, the name of the container is CTRL. And then -it is a command that you're passing, which says, I want it to be interactive type. So I can type in there, and then I want the latest. Alpine latest is the name of the engine. So Alpine is the image, and then colon, and then latest is going to be the tag. So that could be a version like Alpine colon 3.1.1, and we would get that exact image. It would pull it down from the Docker repository. All right. So when you type a command like that into the command line, the Docker client converts that into its appropriate API payload and posts it to the correct API endpoint. So once the daemon receives the command to create a new container, it makes a call to containerd. And despite its name, containerd cannot actually create containers. It uses runc to do that. So it converts the required Docker image into an OCI bundle, tells runc to use this and create a new container. So you can see how other implementations, once you get to containerd, if you're following OCI, it's going to be able to run all those containers on the same runtime client. So runc interfaces with the OS kernel. That's your operating system to pull together all the constructs necessary to create the container. The container is processed and started as a child process of runc. And as soon as it is started, runc will exit. So again, you end up with just your application running and everything is working. So just a summary, the Docker engine is modular and based on open standards. It's a container execution is handled by containerd. Containerd is the container supervisor. It handles the lifecycle of the operations, and it uses runc as its default container runtime. And again, you can see how the components are starting to come together. And that brings us to the image itself, which is the core piece. And again, there are other ways of creating images from your applications, and we are going to be focusing on Docker for simplicity because it's going to be one of the easiest ones for you to find, install, and start playing around with. So let's talk a little bit about how images work. And we're getting really close to doing some demonstrations. So that's where the fun kicks in. So we've got Docker images, and remember, they're like virtual machine templates, right? So a virtual machine template's kind of like a stopped virtual machine. So a Docker image is like a stopped container. Images are considered a build time construct, whereas containers are a runtime construct. So in your head, if you're thinking, well, where does this fit into my CI/CD pipeline? That kind of tells you right there. You've got the build time, and then you've got the runtime. In between there's a deployment. We'll get to that shortly. So we start by pulling these images from an image repository. The most popular one to get started with is Docker Hub, but others do exist. The pull operation downloads the image to your local Docker host, where you can then use it to start one or more Docker containers. Once we've started an image, the two constructs become dependent upon each other, and you cannot delete the image until the last container using it has been stopped, destroyed. So image is made up of the multiple layers as shown here. So that last piece, let me go back up 1 second. So yeah, so if you've got a container that relies on an image, you won't be able to delete that image. And so that's part of that Docker engine and client. It's keeping track of all of that. So you can't delete the underlying image if it's being used. All right, so what makes up an image? It's multiple layers that get stacked on top of each other, and that represent a single object. Inside of that image is a cut down operating system and all of the files and dependencies required to run the application. So you can kind of think of each layer as a set of files and folders, and then also each layer is a delta. It holds the delta between each layer. So the containers are intended to be fast and lightweight. The images tend to be small. So the purpose of the container is to run an application or service only, not an entire set of applications and services. So it means the image containers created must contain all of that operating system and application files, but you want just enough of runtime to run your application. All right, so Windows-based images tend to be a little bit bigger. That's just the way that things tend to fall. And Linux-based images, because of the way, it's just the way Windows operating system works, so you have to include a little bit more in with your images. And we'll talk about building images, and we'll actually take a fairly simple .NET application and we'll build an image from it. So a Docker image is a bunch of read-only layers. Docker takes care of stacking these layers and representing them as a single unified object for us. We can see these layers using the image inspect command. And so in the sample, we can see the image has this image here has 5 layers, and each layer is represented using their SHA-256 hashes. All Docker images start with a base layer, and as changes are made and new content is added, new layers are added on top of that. As an oversimplified example, you might create a new image based off of Ubuntu Linux 16.04. That would be like the first image. And then if you added a Python package, that would be a second image on top of that. And if you then added like a security patch, there'd be another layer on top of that. So you don't have 3 layers on your image in that scenario. All right. So let's go through and pull and inspect some images, and we'll just play around with Docker and get used to what that looks like. And then we'll go over some of the commands. So again, I've got Docker installed. So if I just type Docker, let's start there. It's going to give me a list of all the things I can do. So it's a great way to get in here. There is, it's kind of like your help is just typing in Docker. You can do, Docker version to see which version you're running. This can tell us all of our things. Again, here I am running the Docker engine on community. The version is 19.3.8. And then my operating system is Windows. And there we have all of our stuff. And then here's our the Linux one too. So you can run either one. I'm actually running Linux right now, I believe. So let's take a look at what we have on here. So if I go Docker, so the commands go Docker to tell your command line what you're doing. And then the thing you want to do. So in this case, I want images. And then what I want to do is list them, and that command is ls. Sorry, it's Docker image. I said images because that's what I wanted to see, but the command is image, and I have a bunch. That's why I knew that wasn't working. I knew I had typed something in wrong. Looks like someone's saying the volume is gone again. For some reason, my questions are in a very small window. All right, hopefully that's getting resolved for folks. So here are all of the images I have on my machine. And if I want to look for containers, I can do the similar command. I can do Docker container ls. And the container ls is only going to show me containers that are running. But if I do the same command with -A for show me all of them, it'll show me all of the containers that I've created in the past. So I've created this container and this container. I created one called persist. These are all still exist. I can delete them, and then they all have like, this is the image that's underneath it that was running on it. And so I can start those up again if I want to. They're still out there. So let's do it. Let's pull an image. Let's see if I have it here. Let's see. I do have this one. So what I'm going to do is I'm actually going to delete this so I can repull it. Let's see if that'll work. Because it may cache it. Docker image, and then it's remove image as RMI. All right, so it's untagging and deleting all of the layers that make up that image. So if I go Docker image ls, that should be gone. All right, so now let's go through and pull that image down so we can see what that looks like. So if we do Docker pull, and then we just give the name of the image. In this case, it's Microsoft ASP.NET Core. And I didn't add a tag. The tag would be colon and then whatever version I wanted. So it's just going to pull the latest version from Microsoft. And if you don't specify, it'll automatically say that you want the latest. So even if you have it downloaded on your machine, it'll still go check for latest and see if that image is different, and then download the newer image for it. All right, so now I've got that. Now let's inspect that image and see what's inside there. And that's going to be Docker image inspect. And then the name of that image. So it's Microsoft ASP.NET Core. All right, so we have a ton of information. Let's go up to the top. All right, so we are not necessarily going to want to look at all this information every time, but if you're wanting to find something out, like have your image work with something, and maybe you're using it as a base image for some technologies, you can look in here to see if there's anything that might be throwing you off. Again, this is the repo tag that we pulled it from. This is the ID, so your SHA-256 ID for that image. And then, so there's our digests and whatnot. So this is everything that the API gets when it calls out and says, I'm looking for this. This is what's returned. And it uses all this to run this. And it talks about, the images. Again, a lot of this is not super readable, and it's a little bit, if you go in here to troubleshoot, you're probably going to be a little more advanced. But what we can see is the layers. So here's the layers that make up our image. And so this is going to be one layer. You can think of that as like the base operating system, and then there's probably some application layers and then some supporting files that go along with that. So this doesn't actually take us all into everything that it does, but we're going to build one from scratch or from a Docker file, and we will see what that looks like. So that's pulling and inspecting a Docker image. You could pull a bunch of other images. We could also inspect something like Docker. I've got Mongo on here, so I could do Docker image inspect Mongo. And here you can see we have a lot more layers. Boom. And then if we did the same thing with Alpine, Alpine is going to be a runtime that we would add to some of our projects. And you can see it is very small. It's a single layer. So that's the difference between Mongo is this whole entire thing that you're using. That's MongoDB. It's got database. It's got all kinds of tooling on there for you to use as a database. Alpine is just a runtime. It's designed to be the smallest amount that you can use to run your application. So you can see it only has one layer. It's very simple and easy to add to other images. All right, let's take a look now at what we just did. So we did the image pull, and then we have the repository, and then the tag. So in this case, if we did Docker image pull Mongo, and then the tag would be 3.3.11, and that would be like a version number. It can be plain text. You can do, you can tag your images in a lot of different ways. Generally, though, it's some sort of versioning that you're using to keep one deployed image separate from another, especially if you're developing an application. So as part of each command during that image pull demo, we had to specify which image to pull. And that was exactly how we told it. And we left off the 3.3.11, and it just pulled down the latest. All right, so the image registry, what that does is stores the images for us. So we don't have to have all of our images on like a developer machine. We don't have to create a repository where it's coming from. We don't have to like figure out a way to retrieve these files and then run them. That's already been solved for us. So image repositories can contain multiple, or image registries, sorry, can contain multiple image repositories. Again, the repository is what you name it, and then its version. Excuse me. Docker Hub also has this concept of official repositories and unofficial repositories. And the official ones have been vetted by Docker. You're going to find that they are held to a standard of having up-to-date, high-quality code. Unofficial repositories can be a bit more challenging to work with. There's no guarantee they're up-to-date or well-documented or built using the best practices. So it's always recommended for building your images to use base images that are on the Docker registry or some other place where it's been vetted and to be able to be used. Now we can also store our own images there, and they have private registries so that you can deploy directly to a private registry, and there's other private registries as well. So if you're working in Azure, you might want to use like an Azure container registry, and that's going to be something that you deploy, you have complete control over, but it works exactly the same and uses the exact same Docker commands. So you don't have to actually change your workflow at all. You just have to connect to that registry and everything will work from there. Okay, so let's go look at the official registry. Let's see what that actually looks like. And I'm going to grab a link directly to one, and then we'll play around here with what's in there. And if you've heard of Nginx, I'm just grabbing a clean window here to bring over. I'll bring over Azure. All right, so we're going to hub.docker.com, and this one is Nginx. And this is what you can expect from a Docker official image. Again, this one's been vetted, official build of Nginx. And so you have a lot of information here to go through, but the main things you're going to get are the supported tags and respective Docker file links. So if you want to pull in Nginx and then use the tag, colon for the tag, and then 1.17.10, you're going to get that. You can see what it is. It's also the latest. If you want to roll back to 1.16, you can do that as well. They've got like Perl and Alpine, depending on what you need. So if you use Nginx and you know how to use it, this is how you get to the thing that you need. They have quick references, so this is going to link you out to their own documentation that lives elsewhere, but they're also going to provide what is Nginx. Nginx, pronounced Nginx. And then they talk about how to use it. So they give you some hosting samples, they give you some sample run commands for the image, and we're going to run some images in a little bit. And they go through all of that. Now, if you want to do anything else, it's as easy as searching. So let's say I wanted to do Azure CLI. There's an image for that. So if I have Docker, but I don't want to install Azure CLI, or I want to make sure that I'm always on the latest version of Azure CLI, I can do that. Or if I'm on a host machine or like a virtual machine, and I know this virtual machine has Docker, but I don't want to install everything else, I can literally use Docker to spin up Azure CLI and open up a connection to it, and then start firing off command lines like AZ login. I can log into another account and start doing things. So here's a way of running it right here. Docker run -it means you're going to get the command line, and then you get the image right there, and then whatever version you want, and that should allow you to start typing into the Azure command line. So if you have software that requires Docker, you could definitely have your software run these commands. It could pull up a CLI, log into your Azure account, and then write things, create things for you, like create storage accounts or do whatever. So if your software needs to do that sort of thing, you can guarantee that you have the exact running version of the Azure CLI that your commands will run in by specifying that it's there. In the specific image, you've tested your software. You know that if someone runs your software on their machine, it's going to run the Azure CLI version that you say your commands will work on, and your commands will work. So that's some of the benefit of using these these other images. So you may have this installed on your machine, but you may still need to build software that actually uses the image, because you're going to then send that software to other people's machines, and you want to make sure that everything you build is going to work. You can also do things like Mongo. You can go visit their page. They've got some like Mongo Express or the main Mongo client, and it's going to give you some samples and give you some versions, and then you can look up some of the features that may be on some of the versions. I don't think they list beta so much here for these, but some of them will list beta versions if you want to get in and try out some new features that are coming out. Mongo is pretty stable. Don't have everything off the top of my head that would be experimental, but you have some other things like BusyBox. You can find out what that is. You got IBM Cloud Automator, some other things. Let's see what BusyBox does. BusyBox combines tiny versions of any common Unix utilities into a single small executable. So if you're building something Unix in an image and you want a bunch of the utilities, you can install BusyBox. So again, these are things that are going to show up as SHA layers in your final image. You may do like Alpine or some other things, and then get your BusyBox or Ubuntu or whatever it is you're doing. Ubuntu probably has some of the utilities you need. But if you've already built your software at a VM, a lot of times you already know the tools that you're looking for. You can do things like Redis. They've got an image as well. So if you need to use that inside your image, you can pull that out as well. All right, so that's enough of that. That's Docker Hub. All right, so to summarize that section, Docker images are like VM templates. They're used to start containers. You build them in layers with the things that you want. Those layers are designed to be as small as possible and still perform. So you may end up adding multiple layers to get things that you would normally have if you were installing a full runtime onto a VM. But it's still going to be ultimately smaller because you're only going to use the parts you need. And when the layers are stacked together, they make up the overall image. And again, what happens when you pull down those layers is Docker then turns those individual layers into an image. And that's going to come into play when you talk about like Azure CLI and private containers, registries, where they're going to be encrypted at rest in the case of Azure ACR, and then decrypted in transmit, and then they're going to be put together as an image on your client. All right, let's carry on. We'll talk about the container section now. All right, so container is the runtime instance of the image. I've got some diagrams and stuff, but we're going to go, I think, right into some examples just so we can see it working. You can do all the things you would expect, like container start, stop. You can do RM, which is remove container. So without going into the big history lesson on all of these, it contains the containers share the operating system kernel with the host. So if we run a container on our image and we're running it in our Docker Linux, it's going to run off that Linux kernel. And then we can do all of the cool things that we need to do. We do have a diagram here that kind of shows how they all work. That circle in the middle is running, Docker stop, and then it fires off the die command, and then there's the start, which fires off the start command, and you can do the create and whatnot. This is kind of the OSI here, but what we're going to do is, since we're getting close to our hour, is I'm just going to jump in and we're going to run some containers and do some demos here to take us through out to the end here. So we're going to jump straight into our, let's see, we're going to run, yeah, let me jump into this. So I've already connected my command line with my Azure account. So I'm already logged in. So what I'm going to do is I'm going to go ahead and create some things in Azure really quick. So what I'm creating is a resource group. Let me give it a name. Let's see if my resource group will work. We'll call it my resource group 1 just to be safe. And I'm going to put this out here where I live on the West Coast, West US. All right, so now I've got, or I will have shortly, a resource group. All right, and I'm going to create Azure Container Registry. And so what I'm doing is I'm creating a registry, a private registry, and then I'm going to connect to it. And then I'm going to pull an image from Docker, and we're going to run it. And then we're going to retag it and push it up to this repository. So this will give us a full life cycle of what we would be doing to build, like if we were using base layers and building our other stuff, and then we're going to containerize an application. So I have this ACR create command, and then I'm going to put in my resource group, which is my resource group 1. And then I'm going to make put this also in, or I'm going to give it a name. My ACR1, we'll keep it the same. And then I'm going to set the SKU to basic. All right, so it's going to go create an ACR for us. All right, so what I can do is let's see, the DNS name, my ACR1 is already in use. So that's easy enough to fix. We'll just change the name. So those have to be unique. All right, so there it's going through and it's creating all of those things. So to build a Docker image locally on our machine, and I think what we're going to do, since we're running low on time, is I'm going to go through the Docker image, and then we're going to run the command really quick. So I have a file folder with an application in it. Let me show you that. So here I've got this file location, and inside of here I've got a Docker file. This Docker file, let's open it up for you. Fuse. Oh, that was not helpful. What I want is, I'll do it this way, since I need to be in this folder anyway. It's not going to take me there. No, it did take me there. Check that out. So if I go, all right, so I have all my things in there. I could just go code dot and open up my code, and we should be able to see our files. All right, so I've opened up code. If I'm going a little fast for folks, it's because we're running a little bit out of time, but this Docker file is what we want to look at here. So quickly to explain how this works is we've got this from command, and Docker files have this idea of everything you do in here is kind of cached. We've given it a name, and the reason we give it a name is that every from command is like a pointed, like an index in an array. So the first one is 0. But if we were to rearrange this Docker file, then its point in that array would change, and so you give it an alias instead, and then it'll never change. What we do there is we run we copy in the csproj file, and then we run .NET restore. So we're in the folder with all of our files. So it has access to all of those files. It's going to copy in the project and run restore on it. It's going to pull from the files in the local folder. And then we're going to copy to this out variable the restored. After we restore it, we're going to run .NET publish. We're going to publish that, and we're going to copy that out. And then this build SDK is not going to come with us on our image. This part here is going to be the part that creates our image. It's going to pull in just ASP.NET 2.1, just the runtime, and it's going to copy in the published files. And then we give it this entry point that says, hey, you're going to run .NET, and this is the DLL that it's going to create for us. And so that's the Docker file. It sits in the folder, again, with all of these files here, which has our root and app settings, etc. So if we want to build this image, the command is going to be docker build. And we can just give it any name we want. So we can call this web site 1, and we can give it a version 1.0, right? And we are in this folder. So we give it the path of the dot. And it's going to go through and build out this image from that file. So it's running the restore completed, and then it's using the cache. You could say we're copying over our out file, and then it's building us an image. And so now if we do Docker image ls, which is going to list out all of our images, we should see website 1 version 1.0 is now a new image, and we made it 10 seconds ago. All right, and if we want to run this, right, so we have our website 1 is the name of our file. We can run this container. We can do Docker container run. Now -d means we're going to run it in the background, so we're not going to run it inside this command window. Let's give our container a name. Andrew's container. I'm fairly certain I haven't used that one. -p is going to be ports. So if I want to open up port 80, I can. I think I've got something running on that, so I'm going to open up 5001. 5001. We're going to open that up. So 80 is the one that's running inside there. And now I'm going to put in website 1, version 1.0, and because that's the image I want now to run in this container. And so it gives me this this hash, and it says it's basically running. So if I were to do Docker container L, remember we ran this before, there was nothing running in there. So it's running this, the command is .NET, there's the ASP.NET getting started. It started 13 seconds ago, and it's running in Andrew's container, right? So if we go now to localhost 5001, whoa, to line up my fingers when I type. So there's localhost 5000, we want 5001. There's this brand new application. This is basically what you get out of the box if you create a brand new .NET MVC. I've added some custom text to it. There's our ASP.NET getting started. That's actually the name of our file. So that was the name of the DLL that's running in the background. And now anywhere I send and run this container, it's going to basically be this whole website here. All right, so let's stop that. And then we can go through and stop our container and whatnot too. Now, if you want to push this image to our ACR, we have to remember what our ACR name was. And it's my ACR. I'm going to copy this whole thing, even though I need the first part first. I'm scrolling kind of quickly because all of my subscriptions are on here. So I'm going to go to Notepad, drop that in there so I have it. And now I need to connect to my ACR. So I can log in through Azure, doing AZ, ACR, login, and I have to give the name of the ACR, which is my ACR. Oops. 1233. That's going to tell me whether I'm logged in or not. Login succeeded. Great. Now I don't need to get the whole image tag. You can do this where you query in to find out the full image, but because I have the command that I ran, the full qualified domain ID is the Azure CRI, this right here. I can query for that if I need it. But what we're going to do is we have to tag our image in order to push it to that repository. So we're going to do Docker tag. And we're going to tag our website 1. And we're going to tag it with our registry. And then we add back in the repository, which is this right here. So we're elongating the name, right? So this part here is my registry that I've created. And this is the repository that I'm sending up. And so if I start changing the version numbers, you can see they're going to be separated out. So if I click this, we'll get a tag. Make sure I'm on the right window when I click Command. Looks like it's thinking. There we go. That shouldn't take so much. If I do Docker image ls, inside of here we've got this new one that we just tagged. Okay. So now that it's tagged with the name of the registry, it knows not to send this to, or try to send this to Docker. It knows to try to send this to our ACR because we've given it the fully qualified domain name of our registry. So now we can do Docker push. And we can do this full name here. And it's version 1, so we're going to do just add our version in, it's 1.0. So now you can see what it's doing. So we have this image that we've created, and it's pushing the individual layers up. So you can see that it's sort of decomposing the image that's able to run on my machine, and it's sending the individual layers up to the registry so that it can be composed into another image at runtime when we run it in a container. And as soon as this is pushed, what we're going to do is we're going to go ahead and create a container instance and push it there, and then we'll go watch this run on the internet, and then that'll bring us through this life cycle of what images are and how to get them into the cloud. And start sending some questions in if you have them, because we're already a little bit over time. Looks like we've already lost just a couple of folks, but I definitely appreciate your guys hanging out to the end here, because this is the fun part. All right, so that's pushed. All right, so the next thing we need to do is in order to pull an image from our Azure Container Registry, it might be helpful actually to look and see our resource groups. We have my resource group 1, which we created, and inside of here is this my ACR 1233. So we created that in Azure using the AZ commands. And once we get inside of here, we can look inside the repositories, and we've just pushed one up. It's called website 1. If we go in there, we see there's a tag 1.0. So now if we send out website 1 with version 1.1, that'll be a separate image that's in here, and we could pull it from here to run it from somewhere. So we're going to go ahead and do that from the command line. So that's just a visual to keep us on track. And so now what I need to do though is I need to turn on an admin enabled feature. So I'm going to update my ACR, and I need my ACR name again, which I believe is AZ ACR 1233. No, it's my ACR 123. Sorry, I put it on Notepad, then I deleted it. So let's go quickly to Azure. Yep, my ACR 1233. All right, what else do I need to do? The thing I need to do is I need to create admin enabled. You need to set that to true. Now I can do this in the portal as well and grab some information, but I'm going to, okay, so we've set that to true, and we're going to get a credential now so that we can create something with our image. That's my ACR. Again, so we're saying I want to show a credential for my ACR, and I'm going to query a particular item. So if you've never done this in Azure, it's actually really powerful. And the thing I want is passwords. The very first one, and I want the value. All right, so this right here, I'm going to copy that. All right, because we're going to need this for a command, which is going to create a container instance and run that application. So we've got AZ container. So we're all in the cloud now. Create. We're going to create an Azure container instance, which is a very easy way to resource group. We're going to use the same resource group. Sorry, resource group. And we'll use my group 1 since we just created that. And we're going to give our name of our container instance, ACR quick start. Oops, sorry, I need to do name, ACR quick start. And then we have to tell it the image we want to send. And again, it's going to be that same image that we had posted before. So if we go up here, then look for my ACR, this whole thing right here is our image, and the version number will add that too. So we'll go space, version 1.0, because that's the one that's in the registry. So if we put a different number there or a different version, it's going to fail because it'll say that image does not live there. All right, so now we're going to set some values for our container instance. We're going to set our CPU to 1, and we're going to set our memory to 1. And we're not going to go into these settings here, but essentially it's like a VM. You're setting how much CPU and memory you want. And then registry username is going to be our ACR name. So that's the my ACR 1233. That part's easy, but then we need the registry password, and that's the thing that we just grabbed. And I'm going to paste that again. Here. And then I'm going to do a couple more things. We're going to set a DNS name label. Let's see, we'll call that ACR demo. And then we'll do ports, and we'll set that to 80 because that's what we want to have open on our container. All right, so this should work. And it'll take just a little bit of time, and we'll see what happens. So now it's running that command. I think it's validated all of those things. And then once it's done, we can actually query for the IP address, the fully qualified domain name, and then navigate there. We can also go into the Azure portal and see that. All right, so we've got all this. It should be there. Let's see if we can get the fully qualified domain name. I'm going to cut and paste this for time. Go back and select our resource group, which is 1. All right, and so again, what we're doing is we have this ACR quick start, which I believe was the name I used, ACR quick start. I spelled it the same. So that should give us a fully qualified domain name. ACR quick start. Oh, I see what happened. I hit an extra key, which changed our command. All right, so there's our ACR demo because we gave it that was our DNS name label. So if we grab this and go to the internet, we go here, there's our same web page it's running. So now let's look at this in Azure really quick. Again, we have to accept it, but there's our ASP.NET getting started. It's got my name on there. Let's go back to our resource group and look and see what's created inside of there. Refresh it because it hasn't refreshed. So what we've done is we have an ACR registry. In there was an image. We created a ACR, an Azure Container instance, which is a runtime. And then we deployed our container or our image into this container. And it shows, here's our image name, website 1, which we renamed it and retagged it from our MyACR. And it gives us all of the state, and it tells us the name that we gave it, which was ACR Quick Start. And if we go to the overview page, it shows this FQDN, which we had said, hey, for the DNS name label, use ACR demo, and then it's West US, and this part's going to be the same. It's going to be your region, and then azurecontainer.io. And we can stop and start our container from here. We can use Azure commands to do it. So we've taken now an application that lived in a folder that looks like this. So here's our whole application. It's got a solution file and a project file and all of our things, all of our views, and we wrapped it up into an image. We tagged it. We created our own private registry, and then we used the command line to deploy that into a container instance. Now, we could also deploy this as a web app for containers and app services in Azure. We could deploy this into a Kubernetes cluster, all from the command line. That involves a lot more tools and a lot more goings on. So we're over time, but we covered all of the examples that we had ready for you. And I'll open this up for questions now, and hopefully you've been sending them in. This is the YouTube channel. It's got kind of a GUID on there, but it's Opsgility. You can search for us on YouTube as well. And you can see that there are different versions of different webinars and expert talks on here. And this is a growing list all the time. So I might want to save that or subscribe so that you can see when the new items come out. If that's all the questions, and you can also send feedback through the channels, Twitter and whatnot. You can ask more questions. You can go to opsgility.com, go to the website here. You can also find more information on skillmeup.com, which is owned by Opsgility, and there's a lot more information there. You can sign up and get webinars, labs, lectures, hands-on, all that whole thing. So I hope you all had a great morning. Thanks for joining us, especially if you're in the West Coast. We started a little bit early, and we went a little bit long, but hopefully it was short and sweet and takes you further into your containers journey. And with that, I'm going to go ahead and sign off, and we'll hope to see you on an upcoming webinar. Thank you. Wait, nope, someone asked a container. Let's see. If I pull an image, create using Linux OS to Red Hat OS, or does it matter for the container to run? So the container is going to run in a runtime instance. So whatever operating system that is on the container is going to be what it runs off of. So as long as you have a container runtime running, you're including the runtime, and it should be on, and it's either going to be running on Linux, your container runtime, or your container runtime is going to be running on Windows. So that shouldn't matter as long because it's only pulling that the base operating pieces. Everything the app needs to run is going to be included in your image. If for some reason you're running a Red Hat version that you cannot install a container runtime onto, then it will not run. Because you have to, so if you're just running it specifically on a VM, you're going to have to install like Docker or some other container runtime like Kubernetes. And that'll take care of the rest of it. Once you have that installed, your containers will run. I'll stick around for just a second in case there's more questions. All right, stay safe, everybody. I'm going to go ahead and end the webinar. And again, you can go to our YouTube page. You can go to our other company, Skill Me Up, and find some other very good information there as well. And have a great Tuesday, great rest of your week. Again, stay safe. Thanks for coming, and we'll see you next time.